So how can we show that a sentence is a validity, contradiction, or contingent? Our general proof strategies are going to be as follows. If you want to show that a FOL sentence is a validity, it is best to begin by supposing that it is not an FOL validity, meaning we suppose that there is an interpretation on which it is false, and then we show that this assumption leads to a contradiction. And since there are no contradictions, we can then infer that the given sentence is an FOL validity. Now, if you want to show that an FOL sentence is a contradiction, we are going to pursue the same approach, just in reverse. We suppose that there is an interpretation on which the sentence is true, and then show that this assumption leads to a contradiction. Since there are no contradictions, we can then infer that there cannot be an interpretation on which the given sentence is true, so it must be a contradiction. And finally, that to show that an FOL sentence is contingent, we need to find an interpretation on which it is true and an interpretation on which it is false. Let's look at a few examples to see how that works. So suppose you want to show that this sentence here, for all x, x is either f or x is not f, is an FOL validity. Now, if you want to show that this sentence is an FOL validity, we start out by supposing that it is not an FOL validity, and our proof strategy is going to be to try to derive a contradiction from this assumption. Now, if the sentence for all x, either x is f or x is not f, is not an FOL validity, then there must be an FOL interpretation I on which this sentence is false. And what that means is that some object A in the domain of I does not satisfy the open formula fx or not fx on I. Since if every object in the domain of I satisfied this open formula, then the given quantified sentence would be true on that interpretation. Now, if we assume that the letter D is a name for our object A, and if A does not satisfy the open formula fx or not fx, then the sentence fd or not fd is false on I. Given the truth conditions for disjunctions, that means that both disjuncts must be false on I. So both fd and not fd must be false on I. But now, given the truth conditions of negated sentences, if not fd is false on I, then fd must be true on I. And this contradicts our earlier result, according to which fd is false on I. So here we have a contradiction. The contradiction is that fd both is and is not true on I. And so we have derived a contradiction from the assumption that our given sentence is not a FOL validity. And since we were able to derive this contradiction, we can conclude that this sentence is in fact an FOL validity. Okay, let's see how this works for contradictions. Suppose you want to show that the sentence "there is an x such that fx and not fx is a contradiction." Meaning, suppose you want to show that this sentence is false on all interpretations. In order to show this, we are going to start by supposing that this sentence is not a contradiction. And we are going to try to derive a contradiction from this assumption. Now, if this sentence is not a contradiction, that means that there is an FOL interpretation I on which this sentence is true. And that means that some object A in the domain of I satisfies the open formula fx and not fx on I, since that's what's required for the existentially quantified sentence to be true on I. Now, if A satisfies the open formula fx and not fx on I, and if D is a name for the object A, then the sentence fd and not fd is true on I. Given the truth conditions for the conjunction sign, that means that both fd and not fd are true on I. And now, given the truth conditions for negated sentences, it follows that if not fd is true on I, then fd must be false on I. But that contradicts our earlier result, according to which fd is true on I. So here we have again derived a contradiction. We have assumed that the sentence "there is an x" such that fx and not fx is true on some interpretation, and we have shown that it then follows that a sentence of the form fd both is and is not true on I. And that's a contradiction, and so we can conclude that the sentence "there is an x" such that fx and not fx is false on every interpretation, which means that it is a contradiction.